What's up guys, and welcome to this video on question 3 of the 2018 DBE exam. Okay, so this question is on pretty much one directional motion, so 1D motion, and also a bit of impulse. Impulse. Okay, so let's get into it. In the diagram below, point A is at the top of the building, point B is exactly halfway between point A and the ground. Okay, so basically I'm going to label this as height of B, and this, so it's height B, that height equals height of A, which is equal to 2 times height of B. Okay, so I hope that makes sense, because B is halfway point between the ground and A. So this is basically our datum, or we can call this our reference point. Okay, so we start off with a definition. Okay, so it says define freefall. Okay, so question 3.1 says define freefall. Okay, so freefall is a motion under the influence of gravity only. Okay, so it's basically when the only force acting on a body is the gravitational force. Okay, so we get ourselves 2 marks for that. And then question 3.2. Okay, so a ball of mass 0.4 kilograms is dropped from point A. So the ball is dropped from this point, and it has a mass of 0.4 kilograms, and it passes point B after 1 second. Okay, so it meets that in t equals 1 second. Calculate the height of point A above the ground. Okay, so we want to calculate the height of point A. Okay, so this is a classic UVATS question. Okay, so we're going to take downwards as being positive. So our initial velocity, okay, so when it says dropped, it means our initial is equal to 0. So our initial velocity is 0. Our final velocity is unknown. Our acceleration, because we've taken downwards as positive, is 9.81 meters per second downwards, per meter second squared downwards. The time is equal to 1 second, and the displacement is also the unknown, which we're looking for. Okay, so what equation can we use? So let's use the equation S is equal to ut plus a half at squared. Okay, so S is equal to ut goes away because u is equal to 0. So S is equal to a half times the acceleration, which is 9.81 times 1 squared. Okay, so what we get is that S is equal to 4.9 meters. Okay, so what height have we calculated? We've calculated this height right here. Okay, so this height is equal to 4.9 meters. Okay, but this height is only half of the height, right? So that means that the height, it wants the height of A above the ground. So the height above the ground for A is equal to 2 times 4.9 meters, which is equal to 9.8 meters above the ground. Okay, so that's our answer for this question. 9.8 meters above the ground, because it's asking for the height above the ground. And we get ourselves 3 marks for that. Okay, then it says, when the ball strikes the ground, it is in contact with the ground for 0.2 seconds, and then bounces vertically upwards, reaching a maximum height at point B. Okay, so I'm going to now erase what we have calculated for now. Okay, and basically what we know is once it hits the ground, then it goes up to a maximum height where the final velocity is equal to 0 here. Okay, yeah, and it's in contact with the ground for 0.2 seconds, and the maximum height is that height of B, which is also equal to 4.9 from what we calculated before. Okay, so moving on, let's go. Calculate the magnitude of the velocity of the ball when it strikes the ground. Okay, so again, a classic UVATS question. So question 3.3, UVATS, I'm going to take downwards as being positive. Okay, I'm going to use, the scenario I'm going to use is from the top all the way to the bottom. Okay, so my initial velocity at the top was 0. My final velocity is an unknown. The acceleration is 9.8 meters per second squared downwards. My time is unknown, but this time I know my displacement, and it's downwards, and it is what I calculated, which was 9.8 meters. Okay, and I want to calculate my final velocity, the magnitude of the final velocity. Okay, so I need to find an equation that I can use. Let's try the equation v squared equals u squared plus 2as. Okay, my u is 0, so v squared is equal to 2 times acceleration times s, where that term goes to 0. So v is equal to the square root of 2as, which is equal to the square root of 2 times 9.8, 1, which is my acceleration, times s, which is 9.8. Okay, I'm just going to use 9.8 for acceleration as well, and if I plug this in, let's see what I get. 2 times 9.8 times 9.8 gives me a value of, my final velocity is equal to 13.86 meters per second. Okay, it only wants the magnitude, but otherwise, if I wanted a direction, it's obvious that this has to be going downwards. Okay, so now we get to our final question, which is question 3.4. Okay, let me give myself some space. Okay, and we get 3 marks for that question. Okay, so now it says calculate the magnitude of the average net force exerted on the ball while in contact with the ground. Okay, so this is a impulse question. Okay, so from our equation for impulse, we know that F net delta t is equal to my mass times my velocity final minus my velocity initial. Okay, and I am going to take my direction. Okay, we'll talk about direction now quickly, but basically I'm looking for F net. I've got my delta t, I know what my mass is, I know what my initial velocity is, right? Because my initial velocity is this velocity that I calculated right here. That's the initial velocity at which it hits the ground. So my initial velocity I know. But what I don't know is my final velocity, or the velocity at which it leaves the ground. So that's what I need to calculate. Okay, and the way I'm going to calculate that is by using this scenario right here. So again, I'm going to need some UVATs. UVATS. So my initial velocity here is going to be equal to my final velocity for this scenario. Okay, so my initial velocity is my unknown. Okay, my final velocity is 0 because I'm using it for that height right there. Let's dictate a direction. I'm going to take upwards as being positive. So my acceleration is going to be minus 9.8. My time is also an unknown, and my displacement is upwards, and it is 4, it's half the distance, so it is 4.9 meters. Okay, and what equation can we use? Let's see, we can use the equation v squared. Okay, so what we want to solve for is u. So v squared equals u squared plus 2as. Okay, so v squared goes to 0. So u squared equals minus 2 times acceleration times my displacement. So u squared is equal to minus 2 times 9.8 times 4.9. That's a minus there. So a minus minus gives me a plus. I'm going to erase that, and I'm going to take the square root of both of these sides. And what I get is that my initial velocity was equal to, let's plug it into my calculator. 2 times 9.8 times 4.9 gives me a value of 9,8 meters per second, and that is upwards. Okay, so my initial velocity is 9,8 upwards. Okay, so now I know what that value is as well. Okay, so for this equation, I'm going to take upwards as being positive. So that means that my F net is equal to mv final minus v initial over delta t. Now let's substitute some values. My mass is 0,4 kilograms. My final velocity is what I calculated, 9,8, minus my initial velocity. Okay, remember my initial velocity is downwards, and I have taken upwards as positive. So I'm going to say minus 13,86. Okay, and the time was 0.2 seconds. Okay, and if I plug this into my calculator, I get a value that F net is equal to 47,32 newtons. And it is a positive value. And again, we only care about the magnitude, but if I did want a direction, it came out positive, and we took upwards as being positive, so the direction would be upwards if we wanted it. Okay, so yeah, quite an interesting question, a bit of a long question to end it off, but yeah, nice and interesting, lots of thinking there. So I hope you guys understood everything I said, and yeah, thanks for watching.